Hello everyone, this is Vijay. Today I'll be explaining about normal forms, especially 1NF, 2NF, and 3NF. These are rules that help us design clean and efficient databases. I'll keep the examples very simple so that by the end you'll clearly understand how and why normalization works. First, why do we even normalize a database? Normalization exists to reduce redundancy, prevent anomalies, and make the databases more efficient. When a database is not normalized, the same data is repeated many times. This leads to errors, inconsistencies, and update problems. Normalization fixes these issues by organizing data into right tables. Here's a simple example. We have a physician uh, table that includes SSN, name, rating, hourly salary, and hours worked. But rating determines salary, meaning salary is repeated every time a physician appears. If rating changes, you don't have to update salary in every row. If we if we miss one row, you end up with a inconsistent data. If you delete a record, you might lose the salary value entirely. These problems are called anomalies. Update, insert, and deleting anomalies. Normalization solve this. Now let's look at the first rule, 1NF. To be in 1NF, every field must have atomic values, which means only one value, not less. There must be no repeating groups, and the table must have a primary key. A violation of 1NF would be something like putting multiple phone numbers in one cell or string, or full addresses in one column instead of breaking into the street, city, and state. 1NF basically ensures the data is clean and structured at the basic level. Moving on to the second normal form, which is 2NF. A table is in 2NF if it already is in 1NF and there are no partial dependencies. This applies only when the primary key has no more than one column. Every non-key attribute must depend on the whole primary key, not just part of it. For example, if the primary key is student ID and course ID, but student name only depends on student ID, then the table violates 2NF. Student name doesn't depend on the course, so it shouldn't be in that table. Finally, 3NF. A table is in 3NF if it's in 2NF and there are no transitive dependencies. That means non-key fields must not depend on other non-key fields. For example, employer paid depends employee paid. That's a dependency between two non-key fields, so we must split the table. 3NF focuses on removing these direct relationships so that the table contains only facts that depends on the primary key. Let's look at a quick SQL example of the table that violates 1NF. In this patient's raw table, the phone numbers column stores multiple phone numbers in the same cell. This breaks 1NF because values must be atomic, meaning one value per cell. To fix this, we split the data into a clean table called patient phones, where each row contains only one phone number. Now the database is in 1NF, no repeating groups, no multiple value inside one column. Here's an example of 2NF violation. In this table, the primary key is made of two columns, student ID and course ID. But the column student name depends only on student ID as we discussed earlier, and not on the course ID. That means it depends on part of the primary key, not the whole key. This is called a partial dependency, and it violates 2NF. To fix it, we split the table into two. One table stores student and their names, and the second table stores enrollments. Now, every non-key attribute depends on the full primary key, and the design is in 2NF. This is a classic example of 3NF violation. In this employee table, the primary key is employee ID, but salary doesn't depend directly on employee ID. It depends on the job grade. So the dependency chain is employee ID, job grade, salary. That's a transitive dependency, meaning a non-key attribute is determined by another non-key attribute. To fix this, we split the table into two, one for the employee and their job grade, and one lookup table that stores the salary for each job grade. Now, there is no dependency between non-key fields. Everything depends only on the primary key, so the design follows 3NF. Here's how normalization fixed the table. Originally, we had physician, which contains SSN, name, ratings, salary, and hours work. But since salary depends only on rating, we split the table into two. Physician, where it contains SSN, name, rating, and salary, which contains rating and salary. Now the salary is stored once per rating. If the salary for a certain rating changes, we update it in one place, not hundreds of rows. This removes redundancy and prevents future errors. To wrap it up, 1NF deals with atomic values and repeating groups. 2NF removes partial dependencies. 3NF removes transitive dependencies. Together, these forms make databases more consistent, efficient, and easy to maintain. Thank you.